Hey everybody, welcome back to our chess engine using Python tutorial. So at this point, I gave you guys the task of trying to finish the moves, and then we went over the move solutions, and we also got the computer to put to check whether the player was in check, and eliminate moves that would be invalid in a game of chess. So we did that last video. And I gave you guys two ways of doing it. One was a more naive solution and one was more advanced. Now, the more naive solution actually causes a few problems that we're going to have to deal with in this video. And so if you've done the more advanced version, things might be slightly different here. And maybe at the end of the video, I'll go through my code with the more advanced solution so you can see, but it's going to be pretty similar overall, so you can follow along. What are we going to cover in this video? It's two topics. So the first topic is pawn promotion, and then the second topic is en passant. I was going to include castling, but I'm pretty sure that the video would then be a little bit too long. So we'll cover castling in the next video or in a later video. So what do I mean by pawn promotion and what do I mean by en passant? Let me demonstrate what those are. So in a pawn promotion is whenever you get a pawn to the other end of the board by marching it down the board and capturing pieces. And when you get to the end of the board, it will turn into a queen. Oh, I forgot that I actually have it asking me what I want to promote it to. So give me 1 second. It says promote to queen, rook, bishop, or knight, and I will type queen. And there I have queen. So that's what pawn promotion is. And now, obviously, black would have to capture the queen, and black, whatever, white could make a move, and then black could also go about their pawn promotion, and they would get a queen. Now you can choose to actually promote to any piece you would like. So you can actually promote to a rook, for example, or you could promote to a knight. In most situations, you want to promote to a queen, but there are given situations where promoting to a queen might cause stalemate, whereas promoting to a knight would not. Or a rook or a bishop or something like that. So there's situations where that's necessary. For our engine today, we're going to just focus on promoting to a queen, and I'll talk about how you could go about making the user have a choice to promote, but we'll just always make them promote. All right. The other thing we're going to look at is en passant captures. So let's say that, for example, this pawn up to this square here. Now black can play two moves. They can play this pawn forward 2, this pawn forward 2. And in both those situations, you're sort of bypassing this move here, which would allow white to capture that piece. So by bypassing that, now white cannot capture this square. So there's a rule in chess called en passant where the move after a pawn moves twice, you can capture it, like so. And that prevents the pawns from bypassing each other, like that. So it's just similar to how that would capture. You can capture it that way. So that's what an en passant is. So we're going to add the logic into our engine to do both pawn promotion and en passant. So let's get into it. So I'm going to start in my engine file here. I'm going to pull up my notes. And actually, I lied. I'm gonna start in main. We're gonna adjust something before I forget that is gonna cause us bugs later on if we don't deal with it. So in our main, we have this if move invalid moves, and we make it's important to note here that the move variable that we're making is actually this variable here that is generated by clicks. We're going to be adding flags to moves to indicate whether they're a pawn promotion move or an en passant move. or something to that nature. And when we add those flags in, we need the engine to be able to recognize those flags. So if we do not add them in with the mouse clicks, then our program will not actually recognize those flags, and we'll get some interesting bugs. So to fix this, it's actually pretty simple. We have to just change the way that we're finding this. So we use this new notation here, if move and valid moves. And what this is actually doing is it's valid moves is a list. So Python is going through all of the moves and valid moves, and it's comparing the move that we generated based on the ID that we gave it here, which is based on start row, start column, end row, end column. And it's saying if it's that move, then make that move. That means it's a valid move. Which is all fine and well until we add a few more pieces of information to our move, and now we can't convey all that information. So what we're going to do is we're going to simply take this code that we have here, and we're going to tab it in a line. And we're just going to, instead of using this shorthand notation of if move and valid moves, we're actually going to go through using a for loop on the length of the valid moves. So we're going to iterate through valid moves, and we're going to actually see if move is equal to valid moves I. So you might be asking, like, why go from one line of code to two lines of code? Why make this more complicated than you had than it was? It was already very simple. Why make it more complicated? And the idea now is we can actually say, instead of making the move, we can make the move valid moves I. And the difference here is that this is the move generated by the engine, as opposed to the move generated by the player here. I mean, it's still being generated by the engine, but it won't have any of the specific information that would be in the moves that we're going to add in. So that is why we're going to do it this way. And this breaks one little thing, so we need to fix it. Obviously, this else statement is a little bit different now. Before the else was after the whole for loop happened, we did this. So we're going to basically do a similar thing, but now we know we're getting to the end of the loop if a move is not made. So if the move is not made, then that means we can set the player click equal to square selected like we had before. All right. So prefacing with that, that's going to just prevent us from getting a couple bugs. And if you don't do this part, you're going to get some interesting bugs, and they can be really, really annoying to try to figure that out. Talking from experience today. Okay. Let's start with this en passant idea. And the idea behind, let's start with pawn promotion idea first. So the pawn promotion idea is basically twofold. First off, we need to indicate in the move when a pawn gets to the back rank. So any pawn move that will get us to the back rank, we need to, and by that I mean if I'm looking at my board, if a white pawn reaches row 0 and if a black pawn reaches row 7, then it's no longer going to be a pawn, but it's going to be a promoted piece. We're going to promote it to a queen. So we need to look at all the pawn moves, and when we generate the pawn moves, we're going to first determine, did it make it to the back rank? And if it did, let's transform it. Let's make that a pawn promotion. And we're going to save that information in the move itself, so that if we undo it, we'll be able to put the pawn back and remove the promoted piece. So that's one idea. So not only do we need to generate the move information, but then we also need to actually modify how we make the move. So when we make a normal move, we just say, oh, this is the piece we moved. Let's put it in its ending location. But now, instead of putting a pawn in its ending location, we're going to have to put the queen in the ending location. So we're going to have to modify make move, and we're also going to have to modify undo. So there's going to be some code we add in to make move, to undo move. For valid moves, I don't think we need to do anything with that. We are going to have to add in obviously some information into pawn moves, and then finally we're going to have to actually change our move class. So that's what we're looking at. Now I'm gonna start with what I think is the most logical place, which is the move class itself. How are we going to store this information about a pawn promotion? So my idea is, let's just make a field for a move that is a pawn promotion. So let's just say, is this move a pawn promotion, true or false? And that way, whenever we're making the move, we can just look at this field and we can say, okay, if this is true, then that means I need to change the pawn to a queen, and if it's not true, then I can ignore it. Now, I don't have a field for this, and it's unclear whether or not I should generate this here or in the move itself. And you could do this probably a couple different ways. So this is pawn promotion is going to be, let's assume it's going to be false. Now what we're going to do is we're going to say that if the piece was moved, so here, if piece moved is a white pawn, and so when a white pawn reaches rank 0 and the ending row is 0, that means it made it all the way to the end. So that means that this is a pawn promotion move. So this is just our way of our logicking of logic. I think logicking is a made up word. I just made it up. This is a way of writing our logic to solve that is pawn promotion problem in a pretty simple way, actually. And obviously, we also need to note the black pawn reaching its final rank, which would be 7. So let's do a complex conditional here. No sense in doing another else if we are just changing one variable. Oh, set this to true, sorry. Is pawn promotion true? And so now piece moved is white pawn and row is 0, or piece moved is a black pawn and end row is 7. So in these two cases, it's pawn promotion. And then we have this, now we have this field that will tell us when we're making a move or undoing a move that yes, this is a pawn promotion, and we can use this. So this is just nice, a nice way of doing this. Now you might have thought, like, wouldn't it have been better to do this in get pawn moves, because that's where like all the pawn move logic is happening. But if you think about it, there's a couple different cases when a pawn could promote. It could promote with a 1 square pawn advance, or it could promote with either capture. So we would have to add in extra information into our constructor in 6 different spots in order to make that successful. And so that would be a lot more code to write. And so this is a much more efficient way of doing it. So yeah, let's go ahead and now modify make move and undo move to reflect that. So now we have this, like I said, we have this flag that we can use. So now when we make a move, so we can ask if the move is a pawn promotion. So if the move is a pawn promotion, well, what should we do? Now we could give the user a question, the question of, hey, what do you want to promote this to? King, queen, rook, knight, whatever. The issue with doing this inside of make move is that this is the weird part. The way that if you recall how we did in check, we generated all the enemy's moves to make sure like they couldn't attack us. And so what you're going to end up having happen is when your pawn approaches the back rank and they're 1 move away, and then you generate all of your opponent's moves. Maybe showing this is actually as I'm explaining it might help. So as the pawn approaches the back rank here, what the engine just did was it generated all of black's possible moves. And in order to generate all of black's possible moves, my naive solution was generate all of black's moves, then try the move and generate all of white's possible moves from that. So for example, one of the moves that it would have generated would have been this pawn moving forward one. And then after that, it would have said, all right, now generate all of white's moves. And two of white's moves are this capture and this capture. And so it would have actually paused our code and asked us, do you want to promote to a queen? And obviously, we're not even playing out this move because we just did this and it's black's turn. So it would actually cause this really weird bug. And so instead of asking that question here, which might seem like the logical place to do it, where you'd actually have to ask it is inside of the main. Where we looked at here, you'd basically have to say if the valid moves I is a pawn promotion, then you would have to suggest, okay, do you want it to be a rook, queen, bishop, or knight? And if then they would answer. And then in your engine, you would actually have to add another field to the pawn promotion, such as something like promotion choice. And you would have to actually have to add a parameter to this, and it gets a little bit complicated. It might be something that you want to try, and you'll probably have to use something called optional parameters, which I think I'm going to show later in this video. But anyway, that was a little bit of a sidebar as to why in make move, we're just going to make it a queen. We're not going to test for a queen, a rook, a knight, or a bishop, because the logic gets a little bit messy. All right, so we have this is pawn promotion field, which is going to tell us that our pawn has reached the back rank. And so now what we need to do is we need to simply, instead of placing the piece at the end row, end column, which we've done here, we basically need to, instead of putting the piece moved here, we need to grab the color of the piece moved, which is the first variable, and then just append to it or add to it, string concatenation with the plus sign, the letter Q. And so this will grab the color of what said pawn that's moving to the end and then make it a queen. And that will essentially make this a pawn promotion. Okay. I think that's it for this. We're going to test it out to make sure we didn't miss anything, but I think that should be good. So now let's see if our pawns will promote. We march them down the board. Nobody would make these moves. And there we have a queen. Beautiful. And let's see if also the black queen works as well. And we should test our undo function as well, which, okay, we're reverted back to a pawn. It would be bad if we reverted back to a queen here after we move here. And we get the pawn here as well. So it seems like it's working nicely. So we've tested it. You always want to try and test as many cases as you can because always bugs that will show up. But this looks like it's working pretty well. And so let's go ahead and move on. So the second part of this video now is going to be focused around en passant. And this is a little bit more complicated. So bear with me as we go through this. The first thing we're going to have to add in here is a way to keep track of when an en passant is possible on the given grid. So just as a refresher, an en passant is possible after a player moves a pawn 2 squares forward. So an en passant capture should be possible here. So at any game state, at any given game state, there is exactly one square that could potentially be captured for an en passant square, or none. So I shouldn't say exactly one. There's either a one square or If white makes a different move, now there's no en passant squares. And even if black makes another move, this square is now invalid. So it's only the move immediately after a 2-square pawn advance. So what we're going to do in our algorithm is we're going to actually keep track of this square right here when black makes the move to e5. We're going to keep track of this e6 square and say that's the en passant square. That's the square we should be able to capture. And so I'm going to simply add a variable here called en passant possible. And at the beginning of the game, no square is possible. And so we're going to simply leave this as an empty tuple. But this will be the coordinates for the square where an en passant capture is possible. Now, like we did with pawn promotions, adding information to our move, we're going to do a similar thing to en passant. So there's kind of two pieces to this. One is an en passant capture possible? And then the second is, was the move an en passant capture? And if it was an en passant capture, then we need to, like we did with pawn promotion, we have to adjust our make move function. We'll have to adjust our make move. So I'm going to go ahead and add an is en passant move. And just like we did with the other one, we're going to go ahead and set that to false. Now, how do we know if or what square we're capturing, or if a move given the starting row and ending row, starting column and ending column, was a en passant move? Well, we knew it was like a pawn promotion because we looked at the piece and we looked at the ending row. So let me just reorganize this a little bit. Let's throw this down here just to kind of keep these pieces together. This is all pawn promotion stuff, so this will be all en passant stuff. Try to keep our code well commented and organized as much as possible. So what's the logic here? We have a couple things to consider. One, we have to make sure that the square that we're looking at is actually the en passant square. And we only have the board. We don't have the game state's en passant field that we made. And so we're going to have to add in a parameter here. And I'm going to use the idea of an optional parameter here. So whenever you want to add a parameter, in some cases, you can use something called an optional parameter. And in Python, these are very useful. So not every move should necessarily have this en passant possible field that we need to identify. It's really only after a given move is made where we know this will be possible that we should pass this in. And so we're going to use this optional parameter here to allow our user to recognize that this is the square that we can capture en passant. And so now what I can do is I can look at that square. And if the piece that I'm moving is a pawn and I'm capturing on that square, then it'll be an en passant. So what's that logic look like? If the piece that I'm moving is the type of the piece is a pawn, and the square that I'm moving to, so I'm gonna actually compare tuples here. So I'm gonna compare self dot end row end column with my en passant possible. And then if that's true, then this is an en passant move. So we'll set that to true. And I'm actually seeing something that could make our code a little bit cleaner here. Whenever you have an if statement with just a single thing and you're assigning a Boolean variable, one way to rearrange your code to make it cleaner is actually just to define the value of this field equal to the statement itself. So let me rearrange this just so you can see what it looks like. So now is pawn promotion equals, and then just the return value of this expression. And then I actually don't even need this part here, because if it's false, it's going to be set to false. And I can do a very similar thing to here. So instead of having this if statement here, I can set it there, colon. And then I do need to make sure I put parentheses around this whole thing, because we are looking at this conditional. We're looking at this and that to the return value. All right, so now another thing that I wanted to mention was this en passant possible optional parameter. What we've done up here is I've actually said equals this. So what I've done is I've given it a default value. I've given it the default value of empty parentheses. And what that means is that if I don't define, so for example, when I'm generating moves, I'm not defining any, let's look at pawn moves. When I am generating a move, I'm not putting in a field for that en passant square. And so by default, that square is going to be set to 0, or empty rather. And so the only time that that I'll pass these in is basically on pawn moves, because those are the only ones I need to really worry about. So now let's go up to our pawn moves, and we're going to work on implementing the en passant there. Unlike our pawn promotions, this is a little bit more complicated, so we're going to go ahead and need to add some code here. We need to tell our computer or our engine that it's okay to allow a capture on an empty square. Right now, our pawn captures, there has to be an enemy piece to capture for that to be a valid move. So what we have to do now is we have to say, if the last move that the enemy made was an en passant move, was a 2 square pawn advance, and so now that square is valid for an en passant attack, then we should be able to append that move as well. All right, and so what this is going to look like here is elif. So I'm in the white pawn moves here, and I'm just going to be checking the left capture first. So column -1. I'm going to check this square to see if R-1, C-1, so that tuple that I'm attacking, I want to see if that is my current en passant possible for my engine, for my game state. Now, this is a little bit different than down here. And actually, like, what we probably could do is, instead of passing a whole tuple, let's actually do this. I'm gonna switch this around a little bit. So instead of passing a tuple, let's just pass a true or false, because we're going to figure out if it's an en passant move, so we don't have to do the logic twice. So let's just go ahead and let's default it to false. And then I will show you how to use that optional parameter. And so I'm just going to set it equal to that field. So is en passant move will be based on this field. Sorry about that. I guess I should have just done that. Keep it simple. We're going to do all the logic in the pawn moves here anyway. All right, so we have r minus 1, c minus 1 equals self en passant possible. That's kind of the logic we had down below before. So this will be an en passant capture if that square is the valid square. And so what we're going to do here is append the exact same pawn move that we had before. The only difference is now we're going to tell the move, hey, this is an en passant move. It's not like a normal pawn move. And so we're going to add in the optional parameter here. And we're going to say this is an en passant move. And now I want to rename this variable because en passant possible doesn't make sense really. So let's go ahead and right click here and we'll go to refactor, rename, and we will name this is en passant move just to match. That'll move it there, and then see if it also renamed it up here as well. Yep. So that's the benefit of doing the refactor instead of finding it. You can actually rename it as pretty easily in all the different spots. So now, let's say for this move where we're capturing r minus 1, c minus 1, we're capturing a piece. So en passant move will be false. Here we're capturing a blank square, which happens to be our en passant square, so en passant move will be true. So if we add this optional parameter in, we can give it a value of true or false. But by default, it will have the value false because that's how we defined it down there. So that's how you can use these optional parameters. And I hopefully that's a nice little thing that you didn't know about. You could find some uses for that. Okay. Generally speaking, I don't like copying and pasting code because if you make a typo in one spot, probably going to make another typo. But this is pretty much the same thing. So all we need to do is change +1 and +1. That being said, as soon as you're copying and pasting code, there's probably a way to do it with a for loop, and I'll actually show you that in my other code. All right. And in a similar way down here, so now we're looking at the black captures. The difference here now is we're looking at +1 instead of -1 because the black pawns are moving down the board, not up the board. And then we're going to also do +1 for the column. And so what we've effectively done now is we've embedded the information in the move that this is an en passant capture. And so now we need to do something with that information. And there's two more things we need to do. We need to do something with that information, but we also need to set this en passant square equal to something. So let's go to our make move function. In our make move function, an en passant move is going to be a little bit different. So just like we had for pawn promotion, it's a slightly different move. Our capture or our en passant will have something a little bit different as well. Sorry about that. Got to pull up my notes again. So we need to do two things. The first thing we're going to do is what happens when we have an en passant move. So if move is en passant move, then how does this change? Well, if it's an en passant move, then the only thing that's different between that and a normal capture, just pull up our board again here. So the only difference here is when you have an en passant move, it's just like a normal pawn capture here. The only difference is the piece that you're capturing isn't on that square, but it's on it's on the row that you started at. So it's actually behind where the pawn is finishing. So the difference between an en passant capture and a regular capture is the fact that we actually need to remove the piece from this square here behind the pawn. So how do we do that? Where is that square located? Well, this square is going to be located at the starting row of the pawn. That works for both going up and down the row. It's before the capture, they're on the same rank, so they are on the same row. But it's one column over, so we'll use end column for our variable. And to capture it, we just simply set it equal to 0. So this is capturing the pawn. That's what makes this an en passant move. Now, you'll notice that the logic didn't work yet, and that's because we haven't been updating this field here for an en passant possible. And this is the last thing we need to do. In order to get this to function correctly, we need to continuously update where our en passant possible is going to happen. And this is going to happen every time a move is made, because every time a move is made, the game state changes. And it's only after a 2-pawn advance is when an en passant will be possible. So we're going to update our en passant possible variable. And we're going to do this only in the case of the piece we're moving is a pawn, and it's moving twice. So a clever way of doing this, so we don't have to worry about white and black, a clever way of doing this is we know the starting row and ending row are going to be 2 apart. And so we can do the absolute value of the difference between them. Starting row, starting row minus ending row. So we find the difference between those two, and then we will compare that to 2. So that's kind of a cool way. So this is only on 2 square pawn advances will we update this and give it a value. Now, what square is going to now be valid? Well, it's actually the square between the row between these two. So now we could actually do the average. Because we're moving that square either 2 forward, either 2 up the board or 2 down the board. And so just to give you an idea of numbers, maybe give you a visual here. I like visualizing it, right? Remember, this is row 0, row 1, row 2, row 3, 4, 5, 6, right? So an en passant will be possible if a white pawn moves from row 6 to row 4, difference of 2, and the capture square will be 5. 6 and 4, the average of that is 5. And if we look at black pawns, we have 1 moving to 3, rank 2 to 4, or 1 to 3, that in our notation, the capture square will be 2, the average of 1 and 3. So in order to get it to work for both black and white pawns, we're going to average the start row and end row. So we add up start row and end row, and I'm putting this in parentheses so the addition happens first. We're going to divide it by 2. That's going to be my first coordinate. Why do I have to double divide here? Just as a note, Python, when you do double divide, does integer division. When you do single divide, it does decimal division. So it will leave the number as 5.0 or 2.0 instead of 5 and 2. And so the comparison won't work when we later compare frames. So we want to do double divide to make it just the number 5, not 5.0. And obviously our end column is going to be the same because we could also use start column here. It doesn't matter because the piece isn't changing columns. And we know this because the row's moving by 2. And the only time a pawn can move twice is if it stays in the same column, never capture. So we could use start column or end column there. Either way works. And so then we will say, if this is not the case, so any other move is made, then we're going to reset this en passant possible back to our empty brackets. So anytime a move is made with the engine, we're going to set en passant possible, and then we're going to reset it if it wasn't a pawn move. And so this is essentially like just keeping track of those moves for us. All right, and so now we're almost done. And there's one more thing that we need to do, which is in the undo move function. Our code still wouldn't work at this moment because of the way it's written. Undo move happens whenever we generate our valid moves as we make a call to that function here. And so if we make a move that happens to be a pawn move, and then we undo that move, the value of our en passant possible is going to change as we make those moves. Even though they're not actually showing up on the board, as the engine is doing that, they're going to show up. So we need to do this little trick here, where we're going to temporarily store the value of this square and then reset it after this function is called. So we're just going to use a really quick temp variable. I'm going to call this temp en passant possible. That's what it is. And we're going to set it to en passant possible. Now, when I make moves and I go into my make move and the value of this changes, I don't care because I have a copy of it here. And this works because these are immutable. Tuples are immutable, so it's grabbing the value of it, not a reference to that object. And then when I get to the end, I'm going to simply reset that value back to temp en passant possible. So this little trick here, it seems really innocent. Like, what are you doing? You're grabbing the variable and then you're setting it back to here. But this is just to save the value for when we're generating our moves. If we're generating all the moves, we don't want to change this piece of information, which is really crucial to our current game state. We just have to be careful about this. This is something that, like, when you have to do something like this, it's an indication that you're probably doing something wrong with your overall algorithm. And in general, this algorithm is not very good. And I talked about that in I think 2 videos ago. I talked about why this algorithm isn't that efficient. It's kind of easy to implement, so that's why we did it that way. But again, it leads to some issues that you just have to make sure you're aware of. So this is one of them we can fix. Now, finally, we can undo the move. So what happens when we undo a move? There's now 2 things that we need to keep track of. One is what happens if we undo an en passant move, and the other is what happens if we undo a pawn moving twice. So there's a couple things. So let's start with the undoing en passant. Sorry, I've got my cursor on the wrong screen. All right, so let's undo the en passant move. And that looks like if the move we're trying to undo is an en passant move, then what does this look like? Well, we need to make our end row, end column blank. The tendency when we undo a move is to put the piece we captured at the end row, end column here. But remember, the piece we captured wasn't in the square we ended the pawn capture on. So this doesn't really work. What we need to do instead is make this square blank. So we leave the landing, I'm going to call it a landing square, blank. The square that the pawn ends up on is going to be blank. So we undo that. We've already moved the pawn back to its starting location, so we don't need to do anything about that. But now what we've done is instead of putting the piece we capture on the ending square, which that's not where its original location was, we leave the landing square blank, and now we need to put the piece back on the square behind that landing square. And so this is going to, again, follow this logic of start row, end column we talked about already. So hopefully that makes sense. And this will be the piece captured. And now there's one more thing we need to do. And this might be something that you overlook, but think about what else are we undoing when we undo an en passant move? What do we need to actually set? And what we need to set, hopefully you're screaming at your computer screens right now, and you're saying we need to keep track of this en passant possible. When we undo it, we need to then set our game state to continue that. Otherwise, if you undo an en passant move, you won't be able to redo that same en passant move. If that makes sense. So that's a very crucial piece of this. All right, now finally, our last thing is we're going to undo a two square pawn advance. So in a 2 square pawn advance, then the en passant possible should be set to nothing. In general, I guess you could, since we're basically doing this, you could pretty much set en passant to empty anyway, and it would probably work fine. But this is a little bit, I don't know if it's more efficient. It's more symmetrical in your code, I guess. But the idea here is we're undoing essentially this piece here, right? So when there was a 2-square pawn advance, if it wasn't a 2-square pawn advance move, this was set to 0. So now if it is a 2-square pawn advance move, then it's not. Then if we're undoing a 2-square pawn advance, then we need to set it to nothing. Confusing. So pawn and again, same logic here. We're going to do start row minus end row equals 2. Then en passant possible equals this. And so I think this would work if you just said else. Basically, if you're undoing any move, I don't know, I have to think about that logic a little bit more. Anyway, this will work. Hopefully. Fingers crossed. Let's go ahead and run our code and see what kind of bugs we're going to run into. I think we covered everything, but I always miss some stuff. Okay. Oh, that's a fun bug. So now it just disappears, which is pretty cool. Fun times. See if that's happening on the other side as well. Yep. Cool. All right, so let's do some debugging. So I thought about it for a couple minutes, and I figured out what the issue was. So the idea is in move, and this goes back to we're getting bugs introduced because of the way that we did the make move and undo move in this valid moves with this kind of bad algorithm that I was talking about. We're getting another bug. The issue is that we're making a move and undoing moves, and one of the moves that we're making essentially is this 2-square advance move, and what we need to do is we need to tell when an en passant move is made. Remember, we're setting piece captured to the end row end column. However, the end row end column is blank. So then it's undoing that move, and like we just put in this code where when we make the move and it's an en passant move, we set it equal to the start the start row end column equal to blank. So we're essentially erasing the old piece, but we're not actually adding in the piece captured. So we need to think about that. If that didn't quite make sense, maybe think about this a little bit. Once you see the solution, hopefully you'll understand that it makes a lot of sense. And the idea here now is that if it is an en passant move, then that means that the piece captured, we actually have to tell it what piece we're capturing because it's not on the captured square. Well, it's going to be equal to a white pawn if we move a black pawn. Else, it's going to be a black pawn. So piece captured will be white pawn. All right, and now let's see if this will work. Fingers crossed, and there we go. So interesting little bug. And our undo function works as well, which is good. Let's make sure the other side works. Okay, now let's test blackout. Well, let's make sure that, okay, so we can't capture it now because we wasted a turn. Now let's see if black can capture en passant, which we can. So everything seems to be working nicely. Whew. All right. That's it for this video, guys. This is probably the hardest thing that we've done so far. From a logical perspective, it's not a real simple thing to do. So thanks for sticking with me. If you were able to stick through the whole video. If you want to stick around, I'm going to just really quickly scroll through my code for the advanced version of this. So if you use that other algorithm and you wanted to see, it should only be another minute or two. I'm not going to try and take too long, but let me go ahead and pull that up so you can see it. Right. So the big difference here is I've actually had to use, let's see. You'll see it looks pretty similar actually here. The pawn moves en passant possible. I actually have castling already in here, so that's for the next video, but this part looks the same, so not much difference there. The major thing is, actually, I'm pretty sure most of this is all the same. The major thing is when we do our make move or get valid moves, we don't need to do that that little temporary variable thing. So you don't really need to add that in because the en passant value isn't getting changed. Other than that, it's actually a lot the same. Our en passant is different. 2 square advanced, that's pretty much the same. Pawn promotion, pretty much the same. You can actually add this input in because it's not going to continuously ask, unlike our other one. So, and let's see. With the move, I actually decided to make pawn promotion an optional parameter here, and I actually like the way I did it in the other version. I didn't actually think about it until I was actually doing the video. But I think actually determining pawn promotion in here is better than the way I did it. But let me show you guys the pawn function. So I did simplify the pawn function into one thing for both black and white. So it's structured a little bit different, but this was from the last video, so I already went through that piece of code. But to make it the same for black and white, basically I did this. If it's whites to move, I set this variable move amount to -1, and if it was blacks to move, I set the move amount to 1. I set a variable for the starting row, 6 and 1. I set a variable for the back row, 0 and 7, and then I set a variable for the enemy color. And then you can see instead of like doing +1 or -1, I just do r plus move amount, and that's going to count for both cases. And there we have, if it's in the back row, then pawn promotion is true. And then we append it with that flag. So it's a little bit different. Here we have to do r plus 2 times move amount for the 2 square moves. But again, this captures both black and white all in one. So it's a little bit nicer in regards to that. I still had to do this statement twice. And I could have maybe done this with a for loop with the C-1 and C+1, but I tried it and it just felt a little bit forced. So I feel like separating it into left and right captures is perfectly fine. So anyway, that's some of the code there. So overall, I hope you guys are enjoying this series. And I plan to continue with castling as well as some UI improvements. I'm not sure which I'm going to do next. And then we'll definitely get into some AI as well. So thanks for tuning in, and I will talk to you